up with an equation. Okay, the equation will be some original amount times 1 minus the interest rate to the power of t. So we need to know what the original amount is and the interest rate. And that's going to give us our, or the rate that it decays or depreciates. And so what we can do is we can find this, remember we're dealing with right here a decay factor. There's two ways that you can think of this decay or identify this decay factor. You can look to see how do you move from one year to the next. So if you were to take the difference of these two values, so if you took 1906 minus 18.32, so that's a difference of 74, and we divide it by 1906, that's going to give us the rate, the R value. So if we take this divided by 1906, and put it into decimal form here, we get about 0.04 approximately. And so you get about 4% depreciation each year. And now if you do that for each of these, you'll find that it's the same quantity or the same amount. And now the other way that you can calculate this decay factor that's probably a little bit easier is you can actually find the decay factor by taking the d value at time t and divide by the d value, the value of that boat or whatever the item is, divided by the previous year, so t minus 1. Okay, so if we took 1832 and divided by 1906, we're actually going to get the whole decay factor. So 18.32 divided by 1906, put it in decimal form, we get about 0.96. Now, would these both give you the same values? Is 0.96 the same as 1 minus 0.04? Yeah, it's the same thing. So you can do either of those. Okay, so the first thing is you need to find that decay factor. Well, here's our decay factor. So we're looking at the equation d is equal to some original amount times 0.96 to the power of t. So the only other thing that we need to solve for is this a value. What is the a value? Well, the a value would be the cost or the price of this item at time 0. Right? We have time 1, 2, 3, 4, 5, but we don't have time 0. So what we want to do is we want to move it back this direction. Okay? So you can, again, do this one of two ways. Probably the easiest way is to use this equation right here and to basically say the decay factor, which we know is 0.96, is equal to the d value at time t, so 1906, divided by the d value at the time 1 year prior, so d of 0. So we're finding what this quantity is. So if we solve this equation right here, we'll get our solution. And so you could use the solve feature if you want. You can do it by hand, but if I take 0.96 is equal to 1906 divided by x and solve for x, hit enter, I get about 1985 for that value. And so this should be the equation that you use to model that information.